Hello, everyone. Welcome to the MicroJIT contribution meeting for the 24th of September. As far as an agenda goes, we've sort of settled into a format of updates from Scott with questions on specific aspects of things that he's working on. So at this point, I'll yield the floor to Scott so that he can provide an update on all the things that I'm sure he's been busy with.
Thank you, Andrew. So we have Cascon deadlines coming up, so I've been a little bit split in my attention recently. So there's a few exhibition submissions from the team, as well as a paper submission that all have to be recorded, and I'm doing 2 of those recordings and had to get the slides ready for that. I also had to self-isolate, unfortunately, recently for a few days. So I did not get to finish GCR like I hoped I would have done by this point. But I'm going through that now. I've got the trampolines set up, I believe. I'm currently working under the assumption that all the trampolines are reserved for the helpers by the code cache manager when it makes the code cache. Because the commands I found, or rather the function calls I found for making the helpers, seems to be assuming that it goes through the entire list of helpers in numerical order in the enumerator and does all of them in a for loop. And it seems to be getting called only once, and it gets called by the code cache manager when it's doing late initialization. So if that's incorrect, I'm going to need to figure out how I'm supposed to create the helpers, because I wasn't able to find anything that peeked into the code cache and said, I need the trampoline for this specific helper, and didn't already assume that all the helpers were there.
I think you are correct. All the helpers are, we reserve space for all the helpers.
Okay, perfect. Okay, so that's right so far then. So I'm just right now digging through debugging. I've got some errors, compiling code and checking things, and then trying to fix it. So I don't have any specific updates on GCR questions on GCR. I'm going to soon be moving off of GCR and onto profiling. I read through the Laris and Ball paper that you sent me, Andrew. The paper mentioned that the problem of counting edges, or profiling edges, counting edges, was more or less solved by taking a maximum spanning tree and then picking all the edges that were not in the maximum spanning tree or maximum spanning forest for multiple procedures. Given that you sent me the Laris and Ball paper, I'm assuming that means that we're profiling vertices counting edges. Is that correct?
Yeah, so what the current implementation for the profiling will do is that we will profile. We decide which edges in the CFG to profile, and if the edge is selected and there's a like the predecessor block has a single successor, or the successor has a single predecessor, then we use those blocks to place the counter. If it's a critical edge, then we'll split the critical edge and we'll put the counter in the block created to split the edge. The only difference in the placement algorithm that we use versus what Laris and Ball do is that because the OpenJ9 compiler representation has 2 classes of control flow graph edges, right? You have normal edges and exception edges. We don't, when an exception edge is selected for profiling, we will never split that edge. We only just profile the catch block. That can lead to some imprecision in the overall profile if you have a hot exception path, but it's hardly ever the case that happens, and it greatly simplifies the manipulation of the program, and it also reduces the number of counters you have to place quite significantly, since many catch blocks will have a lot of catch blocks will have multiple exception predecessors. So that's the only real difference between what we do and what Laris and Ball do. I implemented it using a spanning tree using Prim's algorithm. So it's very much in the spirit of Larison Ball with a few tweaks for Java isms like exceptions.
Okay, so the next question I have about profiling then, let's assume that I have everything hooked up for MicroJIT. I obviously haven't even gotten to start on it yet, but let's assume I have everything hooked up for MicroJIT to create or the correct graphs and input the profiling information. What happens on OpenJ9's side if I choose to selectively profile different edges? Like if I choose to instrument different edges, what happens on the OpenJ9 side?
So I think let me just check if your question is, you're going to select a set of edges to not profile and profile everything else. And what does OpenJ9 do to be able to figure out the overall profiling of the CFG from that set of counters? Is that right?
Yeah, essentially what I'm wondering is how does OpenJ9 know which edges were selected for profiling?
So we don't worry about the edges that are selected for profiling. What we do is we have in the persistent metadata, in the persistent data for the method body, we have a data structure which is an array of size 2 times the number of basic blocks, where each basic block has a bit vector that describes the counters that need to be added and subtracted to produce the frequency of that block. So for a block that contains a counter, it's just the block itself, and there's an optimization on that data structure such that while it contains pointers, if the pointer is low tagged, then we take that it's just the number of the block that we need whose counter we need to read. And if it's not low tagged, then it's a pointer to a bit vector, just to save space so that we don't create bit vectors that contain, a single bit, which is a bit silly. But that data structure is populated at compile time and is basically just then is used by the compiler when it comes to look at the profiling information. When it wants to look up the frequency of a block, it just goes to that data structure, and it will add. The data structure has a set of counters to add and a set of counters to subtract. It will do the additions and subtractions, and whatever the number that results is the frequency of the block. And it's actually provable from the theorems of Nuth and then the follow-on work from Larison Ball that you can derive the frequency of any block in the CFG where the counters are derived with the spanning tree formulation such that it is a sum, an addition and subtraction of counters at most once, right? So each counter can only appear sort of once in either in the addition or subtraction. You don't have to add a particular block twice, for example. So that allows us to pack it in the bit vector, and then we don't worry so much about where the counters are. We use the bit vectors to decode to derive the frequency information when we go to look at it.
Okay, all right. So that probably greatly simplifies things from the research perspective, because my idea was that I would, because like we said last call, I'm not going to have very much profiling information to choose good candidate edges for profiling, or for placing the counters rather. So I looked, I also this summer was teaching a course on computer architecture and organization, and there's a big section there about branch prediction. And so because there's some papers and things they reference in that book, and I went back and looked at those papers that talk about the nature of branching and how certain things, once you know which way something's tending, it's going to tend that way very often. I looked a little bit more into it and noticed that there's a bit of a skew there depending on whether you're doing back branches or forward branches. And I'm going to try and see if I can experiment a little bit with biasing back branches and assuming their counts will be higher than we already see from profiling data, and then see by how much I need to scale things to get closer to what the profiling information really looks like when you don't have any bias at the end.
Mm-hmm.
And see if I can correct a little bit. I know I won't be able to fix basically any of the forward branches, and that some of the back branches will be using this bias. If I bias too strongly, it will overcompensate. So I'm hoping to see if I can somehow correct a little bit statically with a bias the problems that I'll get from only getting a select small number of runs. And I wanted to make sure that if I ended up picking something and I got it wrong, like if I generate a profile and the profile is wrong, or not that the profile is wrong, but if I choose edges using a bias, that J9 wouldn't, when it comes to look at it, end up looking at the wrong edges. Like I wanted to make sure there was some mechanism by which I could give OpenJ9 the right edges.
Yep. So that all sounds fine. And I think that the thing is, even before you worry about that, you're probably going to have at least a couple of invokes in the interpreter before, like, one or two even before you MicroJIT something, just to make sure that it's resolved or whatever, right? So if you can get the iProfiler data flushed for the method, even that might just be enough, right? Or even just worrying about things that are unresolved and treating those paths as low frequency and, right, like, I guess what I'm saying is that before you worry about solving like the counter placement problem, it may be worth just seeing where you get to in terms of overhead just with what you have at the moment, because it may be good enough.
All right, that makes sense.
And if the overhead is too high, then of course the natural thing is to try and improve the frequency so that there's less counters on the hottest paths. But if you can at least get what little profiling there is available, then you may be able to do one quantum better, and that might be just good enough to avoid having to build something more complicated.
All right. So that's it from me, but I did not see Harpreet join. Sent her a message to see if she was still coming, and I haven't gotten a response back. So
Okay.
I guess that might be it for today's meeting.
Okay.
Is there
I
anything
guess
else?
could you just sort of give a summary of where you are on the trajectory towards the PR being ready for another round? Since I know you said you were finishing up with GCR soon, I'm guessing that means that you think you're going to be done that implementation work soon.
Yeah, correct. I'm hoping to have GCR done like incredibly soon. I'm right now debugging a problem with my templates for the GCR counter placement. But once I have those things done, I'm imagining that there will only be whatever debugging work is left to do for ensuring that when I do recompile, that it gets recompiled by TR and not MicroJIT.
Right.
And then making sure that it still runs and gives correct results after TR compiles to make sure I didn't mess something up in metadata structures, make sure it compiles and gives correct results for MicroJIT. And if all of those connections are all done right, then I should be ready to push up a new version. I'll still have to do one more rebase to get things up to date on the most recent versions and most recent changes from OpenJ9 in the public, and then retest it again. And when the tests are done, should be ready to push and have the PR go under review again.
Right. Right. Okay. Sounds good. And I guess you've continued your discussion with Daryl about the linkage stuff, and that's.
So that's one of the reasons I was kind of hoping Harpreet would be here, because Harpreet is going to be looking at the linkage things more specifically. She's her entire thesis is going to be around the idea of kind of generalizing MicroJIT, and so digging into kind of pulling apart the calling convention for a given architecture from the compiler's architecture was something that was going to go on her plate, and that's why I'm very concerned that she didn't make it to the call. Hoping everything's okay. She's not. Doesn't appear that she's online at all. Anything. So hopefully everything's fine there.
Okay, well, she can always supply an update via the PR anyway, if need be. And if we need another call, I can certainly schedule one.
Okay. I'll ask her if she needs anything else the next time I speak with her. Getting a bit late here. It's almost 5 p.m.
Yeah.
So I'm imagining it's possible that I'll probably just catch her again tomorrow.
Yep. Sounds fine. Okay. Was there anything anybody else wanted to raise, or any other comments before? Since it sounds like Scott's done, I don't think I had anything else. So is there anything else anybody else would like to raise before we finish up?
For me.
Okay. All right. Well, then I guess we'll finish this meeting up a bit early then. Thanks for the update, Scott. I certainly am looking forward to seeing the HDR stuff working, and feel free to reach out if you need anything else with regard to the profiling.
Perfect. Thank you very much.
Okay. All right. Thanks, everyone, for attending. Appreciate it.
Bye.
Bye.